Hello everybody. The video you are about to see will show publicly for the first time a revolutionary new way for the world to generate energy. With us today is William Mee, who is an expert in the fields of biomedical engineering, computerized electronic instrument design and control systems, software engineering. He's also a maven of general science, marine electric propulsion technology, and hyperbaric systems. Bill will explain to you exactly what is going on here. Bill?
Thanks, Matt, for the flattering introduction. What you're looking at here is a really new technology that essentially eliminates the boiler from a steam generation system. Steam engine technology has been around for, probably 250 years and is still used today for probably 95% of the power generation, both in the United States and throughout most of the civilized world, in terms of coal-fired plants and nuclear fission-based generation. Reciprocating steam engines, on the other hand, largely went out of vogue at the end of the 1950s and were replaced by internal combustion engine technology because they don't have boilers. Boilers require a significant amount of energy to convert water into steam, and for that reason we don't use them that much anymore. There's other things with boilers too. They require a lot of maintenance, they're dangerous, and when they're not properly controlled they can explode and the consequences can be disastrous. Having said that, there are a lot of significant advantages to the steam engine component of the system. They produce a lot of power at a very low RPM. They have very few moving parts when contrasted to an internal combustion engine. They last a long time because they don't move very fast. There's not a lot of friction. They're inexpensive to produce. They utilize a readily available form of working fluid, in this case water, which is 75% of our planet. And another nice advantage is they're very environmentally friendly. The exhaust of a steam engine is water. So it should become clear that if we could come up with a system that would largely eliminate boilers from steam engines, it would give us reason to completely evaluate the use of steam engine technology within our modern society. Consider, for instance, the magnitude of the manufacturing opportunity if boilers could be eliminated or changed to something the size of a carburetor in a manifold, or eliminated completely. Well, we've really done just that, and the demonstration of this system today will give you a clear picture of just what the basics of this system are. Molecular impact technology is really based on some very simple principles of water. Molecular impact utilizes hydraulic energy to fire essentially a pellet-sized charge of water, if you will, into a heated impact chamber. Now, when you generate hydraulic pressures in excess of 15,000 psi, and in our final practical, our actual production operational system, we'll have hydraulic pressures in excess of 30,000 psi, you can accelerate that pellet of water to very significant velocities. In fact, we estimate that we can achieve velocities of nearly 3,000 meters a second. Now, the amount of kinetic energy imparted to the impact chamber when that water collides is really quite substantial. What happens during that collision is you shatter the water into small molecular clusters, if you will, and you also release a lot of heat due to the kinetic energy. Well, that heat from the kinetic energy further heats the incoming water pulses and raises, of course, the pressure inside the impact chamber. Now, in practice, we would have multiple injectors phased to produce a continuous flow of pulsed water that then would be accumulated in a heated reservoir and then delivered to your steam engine assembly through a proper conduit system. It's very important in designing a system like this to heat the cylinders of the steam engine as well as the conduit, because the heated steam, as it vents from the impact chamber reservoir assembly, will actually cool to pressures that are ineffective to drive the steam engine. What we're going to take a look at here shortly is this system in actual operation, where what we have is an electronic control system that electronically pulses these pellets, these charges of water from the injector into the impact chamber at approximately 10 injections per second. As I said, in a practical system we would have multiple injectors phased in such a way that we would monitor the output steam pressure and temperature, and we would monitor the revolutions of the steam engine, which in a practical application would be turning a generator to generate electric power. We would then use this in the case of a marine electric propulsion system, the electric generator, in the same way it does in electromotive systems and locomotives you see every day. You have a generator, you have a diesel engine turning a generator, which in turn is operating a drive assembly. In this case, we'd be replacing the diesel engine by the actual steam engine. So, without much further ado, what I'm going to do is initiate the program to start firing steam. As you can see, this boiler is at atmospheric pressure. In a conventional boiler, we'd have to heat it, we'd have to put coal, oil, or some other fuel source to get the temperature of the water and the pressure of the boiler up to, say, 250 psi, and then we can produce steam. This system will start producing steam almost instantly, and as soon as I tell the controller to stop pulsing the injector, the steam production stops. As you can see, we're producing steam here at probably about 40 psi to each cylinder, and the engine is operating at a relatively low RPM. In a practical system, we'd be putting a lot more steam into this, and the engine would operate at about 540 RPM. You couple that with a power takeoff and a generator, you can produce 12 kW of 60 cycle power. As you can see here, the steam is exhausting. What you hear in the background are the steam explosions occurring in the impact chamber. Now if I turn off the steam, as you can see, the engine stops almost instantly. If I turn it back on again, it starts up. So essentially what you're looking at is a completely electronic means of controlling this apparatus. We're confident that molecular impact steam generation technology will significantly improve the efficiency of steam power generation systems, in part by the elimination of the boiler apparatus and also by more efficiently turning liquid water into a gaseous phase of steam. When one considers the wildly fluctuating cost of fossil fuels, both oil and other petroleum distillates, over millions of installations throughout the world, the significant increase in efficiency would have a fairly profound impact, especially if we look at this from a global perspective. So our thinking, moving ahead to a production version of this, it should have not only a vast market potential, but a significant potential to decrease the amount of conventional fossil fuel that we're using.